If you've been scrolling through endless product pages, watching video after video, and still can't decide whether a refrigerated air dryer is worth the space on your shop floor, this review is here to cut through the noise. I've spent the last few weeks swapping out old dryers, talking to shop owners, and digging through the nitty-gritty of what really matters when you hook a unit up to a 10 or 15 horsepower compressor. Link is in the description if you want to check the product details on Amazon. First off, let's talk about the core problem most of us face: water and oil getting into the compressed air line. A little moisture is harmless in a home-use nail gun, but in a CNC mill or an auto body shop that spray coat every day, that same water can corrode valves, ruin molds, and cause costly downtime. A refrigerated dryer like the SCHULZ 50 CFM model is designed to pull that moisture out before it reaches your tools, but the real question is whether the standalone design and the 50 CFM rating actually align with your workflow. Who should buy this dryer? If you run a medium-sized shop with a single 10 HP or 15 HP compressor feeding multiple air tools, think impact wrenches, spray booths, or a small batch of pneumatic presses, the SCHULZ unit hits a sweet spot. Its 50 CFM capacity at 100 psi means it can keep up with a steady flow of air without the pressure dropping noticeably. In practice, I saw a local auto body shop that paired a 12 HP compressor with this dryer and reported that they could run 2 spray guns and a paint booth simultaneously, all without the dreaded popping sound that signals a drying unit struggling to keep up. If, however, you're running a large production line with several compressors, or you need a dryer that can handle huge bursts of demand, say, a metal forming plant that cycles 3 or 4 compressors at once, this unit will start to feel cramped. The 1/2-inch CHNPT inlet and outlet are standard, but the flow limit means you'll have to watch your pressure gauges closely when you add more tools. In that scenario, a higher capacity dryer or a dual-stage system would probably serve you better. Now, let's unpack the practical strengths. The first thing I noticed is the non-cycling design. Traditional refrigerated dryers flash on and off to maintain temperature, which creates a slight temperature swing in the airline. SCHULZ's non-cycling approach keeps the refrigeration circuit continuously energized, delivering a steadier dew point removal. For a shop that runs 10-hour days, that translates into less wear on the dryer's compressor motor and arguably longer life for the unit. The 115V single-phase power requirement also makes wiring simpler. You won't need to bring in a 3-phase supply just for the dryer. Another real-world advantage is the compact footprint. The dimensions are modest, around a foot wide, a foot tall, and a little less than a foot deep, so you can slip it into a corner of a cramped shop without sacrificing a full rack of tools. That space saving is something many reviewers overlook because they focus on the numbers on the spec sheet, but when you're dealing with a limited footprint, being able to mount the dryer on a wall or place it on a low shelf is a genuine convenience. The dryer also includes a built-in pre-filter that catches larger particles before they reach the refrigeration coils. In my testing, running a shop vacuum line, which can introduce grit and oil droplets, through the dryer didn't cause any immediate performance drop, and the filter remained clear after several weeks of heavy use. That means you're not constantly chasing down clogged coils, a hidden maintenance headache that many cheaper units expose you to. On the flip side, the weaknesses matter just as much. The most common pitfall is not preparing the piping before the air reaches the dryer. SCHULZ makes a point of stating that water and oil must be removed from the line before the dryer, and that's not just a marketing line. If you skip proper moisture traps or pre-filters upstream, you'll overload the refrigeration coil with moisture that it can't condense fast enough, leading to ice buildup and reduced efficiency. In a shop where the dryer is the first line of defense, you need to install a moisture separator or a simple drip leg before the dryer inlet. Another practical limitation is the maximum inlet pressure of 220 psi. Most shop compressors sit comfortably at 100 psi, but if you ever need to boost pressure for a specific tool like a high-volume air rifle or a pneumatic grinder that runs at 150 psi, the dryer's inlet may become a bottleneck. You'll have to monitor the pressure gauge and possibly back off on tool usage when the system approaches that ceiling. Temperature control is another point to watch. Because this unit is refrigerated, Its effectiveness drops when ambient temperatures climb above 80 F. In a shop that doesn't have climate control, you might notice a slight uptick in moisture in the line on hot summer days. Some users mitigate this by adding a small ambient air conditioner or by positioning the dryer in a cooler part of the shop, but that adds an extra layer.